Hello and welcome back. In this lecture, we'll learn how to containerize a simple Hello World web application. The application is written with Python and Flask web framework. The reason we choose Flask is because it's lightweight web framework and very easy to get started. You can visit Flask website to learn more about it. Don't worry if you have never used Python or Flask before. In this lecture, we'll be focusing on how to work with Docker and how to Dockerize a simple web application. We won't get into technical details about Python or Flask. Also, all the dependencies are managed by Docker, so you don't have to install Python or Flask in your local box. It should be quite easy for you to follow along. I just created a GitHub account for this course and uploaded the source code of this web application to GitHub. You'll need to have Git installed in your local box to download the source code. In case you don't, just Google Git installation and follow the instruction to install Git. Or if you don't want to install Git, you can also download the source code from the supplementary material. I already have Git installed on my local box, so I just issue the git clone command here. You might have noticed that I'm using a -b option here. The reason being I'm using different tags for various stages of the code through this course. The source code for this lecture is tagged with v0.1. So after Git downloads the repository, it'll check out tag v0.1 as a new branch for you. Now hit enter to start calling the repository. Let's see what has been downloaded. The repository is named as Docker app. We enter the repository and clear up screen. Let's check what's inside the repository. There are only a Docker file and a directory in this repository. The Docker file is used to build the Docker container for this web app. The app folder is our application folder, which holds our Python code. Just enter the app folder. There is only one file here. This is one Python program which will initialize and start a Python server. Let's check out the code. I'll quickly go through the logic of this piece of code. The first two lines basically import Flask module, initialize Flask and create the application object. The second part of the code registers a view function for a given URL/. When the given URL/ is requested, the hello world method would be called, which just returns hello world. The last piece of this code initializes and starts the Python Flask server. Just be aware that do not use this run method to start an application in a production. It is not intended to meet security and performance requirements for a production server. Instead, use UWSGI or CGI. You can Google Flask deployment options to find more information about it. In this lecture, we'll be sticking with this run method just for the sake of simplicity, as Flask is not the major focus of this course. But make sure you don't do this in production. Here, I'm using the application server at 0.0.0 instead of localhost or 127.0.0.1. This is needed if we want to have the server available externally, so that your app server can be accessed by other containers as well. Now, let's move on to take a look at the Docker file. First of all, it is the from instruction. We're using the Python 3.5 as a base image, which already has Python installed. Then we install Flask 0.11.1 using pip install, which is a Python package management tool. Next, we add a new user, admin. The MS option will create a default home directory for this admin user. And we're setting the default shell of this admin user to bash. The following user instruction ensures that we'll be running the app server under the admin user. In general, you should always set the user instruction in your Docker file to run your process as an unprivileged user within the containers. Otherwise, your process will be running as a root within the container. It is concerned that if an attacker breaks the container, he would have root access in the host machine because the UIDs are the same. In theory, a root user within a Docker container cannot escalate to be root on the host machine, but many people believe that it's possible to do so. As far as I know, it is certainly harder to do so with Docker containers because of the capacity restrictions enforced by Docker. But if security is a big concern, we should stack up multiple safety mechanisms. So as a good practice, we should use a non-privileged user to run the app server. The next instruction is workdir. This instruction sets the working directory for any run CMD. Enter point, copy, and add instructions that follow it in the Docker file. Here we are using /app as our working directory. Then we copy the app directory to the container. Finally, we run our Flask application. Because we have defined our working directory to be /app, so here I can just use the relative path of the app.py file. Now we're ready to build the container for our Flask application. Here we do docker build -t, name our Python app as Docker app, then tag it with v0.1. The build context is the current directory because the Docker file sits here. Just hit enter to start the build. It might take a while for you to download the Python base image if you have never downloaded it before, because the base image is about 600 megabytes. This is how it looks like if everything goes well. Let's check out our Docker app image by running Docker images. See? The first entry is the image we just built. It's time to run our Docker app container. Here we do docker run -d to run the container in the background. Then -p to expose the port. By default, the Python Flask server will be running at port 5000 inside the container. Let's map port 5000 on the container to port 5000 on the host, so that we can access the Python container from our local box. Lastly, just copy and paste the image ID to run and hit enter. See? Docker builds the container, starts it up at the background, and returns us the container ID. Let's access our Python app server to see if it is up running. First, we need to find out which IP the Python server is running on. If you're using Linux, the Python server should be running at your local box. If you're using Mac or Windows, Python server is running on the Docker virtual machine. You can find out the IP of the Docker machine by running docker machine ls. See? It displays various information about the default Docker machine. Just copy the IP of the Docker machine. Then open the browser and copy the IP to the address bar. If you're running Docker on Linux, or you're running Docker for Mac or Docker for Windows, you should put localhost here. We have exposed the port 5000 on the host. So here we just type port 5000 and hit enter. There you go. We get hello world. Our app is up running. We can also log into our container. In order to do that, there is a new command to learn. Docker exec. Docker exec allows you to run a command in a running container. Let's run docker exec -it to run the command in interactive mode. Then we copy and paste the container ID. Lastly, we need to specify which command we would like to run inside the container. In this case, we run bash. Just hit enter. See? We're right inside the container and we're logged in as the admin user. As you can see, we're at the /app directory, which is the working directory we defined in the Docker file. We can also enter the home directory of the admin user. Here, if we do ps-exu, it displays all the running processes on this container. See, our Python application is running under the admin user, which is exactly what we defined in the Docker file. That's it for this lecture. I'll see you later.